So in 6.1, we are looking at perpendicular bisectors and angle bisectors. Central question, what conjectures can you make about a point on a perpendicular bisector of a segment and a point on the bisector of an angle? Perpendicular bisector, we should be familiar with both words. Okay. Perpendicular hits at 90 degrees, bisector cuts in half. So a perpendicular bisector is a line, segment, or ray that hits a line at 90 degrees at its midpoint. Equidistant means that two things are the same distance. The perpendicular bisector theorem says in a plane, if a point is on the perpendicular bisector of a segment, it is equidistant from the endpoints. So in the first picture there, we have line AB with perpendicular bisector CP. So AC and BC are going to be equal, and we then have an isosceles triangle ACB. The converse of this is also true. So if you know that you're on the perpendicular bisector, okay, then that line is going to go through a point that is equidistant from the two things. So AB again is the perpendicular bisector is CP. That line, even though I can't see it on the picture, is going to hit point D. Right? And I know that because AD and BD are congruent. Some examples of problems here. Example 1, AC is on the perpendicular bisector of BD. They want me to find AD. So because it's on the perpendicular bisector, I know AB and AD are congruent. So I set up the problem. Seven x minus 6 equals 4x. Solve that for x. And then since they asked for AD, I want to plug that back in. AD is 4x, 4 times 2, AD is 8. And that is my final answer. Example 2. Right? They tell me Kn is the perpendicular bisector of JL. So they want to know what other segments in the diagram are equal. Right? So I have JK congruent to KL. I know that because of our perpendicular bisector theorem. JN congruent to LN, and I know that by the definition of perpendicular bisector. JN and NL have to be equal, and then JM and LM would also be congruent because they're both labeled as 13. And that is B. Why is M on KM is because JM and JL and LM are both 13. So based on our converse of our perpendicular bisector theorem, M has to be on that line. Example 3A would be similar. What segments are congruent? So we have GF congruent to HF. Don't know what's going on with the G there. So they're congruent because of the 4.1. GK is congruent to HK based on the definition of perpendicular bisector, and GJ and HJ are congruent based on the theorem. B asked me to find GH. So first I need to find X. Based on what we just looked at, I know that GK and HK are equal, so I set those equal. Solve that for X, and I have X is 1. So I'm going to plug that back into both. 2 times 1 plus 1, 1 plus 1, okay, 2 plus 2, and GH has a length of 4. Then I have a similar theorem with angle bisector theorem. Angle bisector theorem, if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So remember, an angle bisector is cutting the angle in half. So if I look at the picture there, the angle at A, BAC, is cut in half. BAD and DAC are equal. And I have the 90 degrees, so I know those lengths are, I'm measuring length from D to B and D to C. All right, so it is the distance between those are equal. All right, and they give me all that information down on the bottom, and what I know is that DB is congruent to DC. And I need that congruent angle, and I need that 90 degrees to know that. The converse is also true. If I look at the picture below that, in the converse of the angle bisector theorem, I have DB and DC marked congruent, and I have the 90 degrees. So what I now know is that angle BAC is bisected. It is cut in half. So angle BAD is congruent to angle CAD. And if I'm marking that on the picture, I would mark it with arcs like this. Again, normally those arcs will be offset so that I know I'm not marking the whole angle BAC. Right? So the difference in the distance from A does not indicate a different size. It indicates that those two, that I'm marking the two different angles. Problems with this, right? Find the measure of the angle CBE, right? So I have the two sides that are congruent at 21 and hit at 90. So the angle is bisected. So my answer there is 31. Do watch what they're asking for. If I asked for CBD instead of CBE, my answer would be 62. Okay. B is asking if I have enough information. I do not have enough information because the angles are not 90. The angle at B and the angle at D both need to be 90. So this is no, they're not perpendicular. You could say something about not 90 or something similar. Example 5, 6, and actually 6A and B are all similar in concept. They're looking at the angle bisector, and I'm seeing things that are equal. Right? Watch what they're asking for. All right, I could ask you for a side length or an angle size. All three of these ask what x is. So all I do is set my equation up. So x plus 1 equals 2x minus 5. solve that, right, x is equal to 6. Right? I would do similar stuff for a and b below. I would set those different equations equal. So a, 3x minus 5 equals 2x plus 5. This is a minus sign here. Okay. Solving that for x, we get x is 10. B, the sides, are equal. So I solve this, x is 3. Again, if they ask for side length or angle measure, you want to make sure you plug in.